Now, the Earth actually has two different kinds of crust. One kind of crust is called continental crust, which is basically the crust on land. We live on continental crust, Africa's on continental crust, Europe is on continental crust. All of the land masses are continental crust. The other kind of crust is called oceanic crust, which, go figure, is in the ocean. These two different kinds of crusts are a little bit different from each other, but the only thing you really need to know is that oceanic crust is a lot more dense. It tends to sink. And when it sinks, it goes back into the mantle, subducting like any other kind of crust that sinks. Whereas when continental crust collides with it, it tends to go up. It gets uplifted. If two pieces of oceanic crust collide, though, they're both already in the ocean, what's going to happen? Let's look at these mountains, which are not forming on land, but in the ocean. I'm representing the ocean as the bottom of this basin, so you can imagine that this will be our sea level. If these were mountains forming at the ocean floor, what would they form above the water? I can show this by adding just a little bit of water to the pan. And then pushing this crust down. If all of this land is underwater, there's still something rising above. The pieces of foil that are breaking the surface of the water are forming islands, a chain of islands which we call an archipelago. Underneath that water is still some crust that's getting pushed up, but it hasn't yet broken the surface of the water. Eventually, that could be part of some new islands, and if enough of it gets pushed up, it could form a new continent. So at the bottom of the ocean floor, new continents are forming all over our planet. And at the same token, if these were to get pulled apart from each other, this continent could collapse.